DeepState is a unit test framework that provides C and C++ developers with a common interface to several symbolic execution and fuzzing engines. We are going to show how DeepState can help developers significantly improve the testing of their software. We are going to see a demo of how DeepState works using a simple function in unit test. In this C++ code, we can see a function that squares a number. There are two unit tests to verify the function works. However, the code contains a subtle problem that can produce incorrect results. The type of the return value of the square function cannot represent all possible results. Some results will be silently truncated to an incorrect value. As expected, the unit tests defined by the developer are not enough to detect an issue in the square function. DeepState allows us to define properties for our own code where the input is symbolic so it can take any possible value. In this case, a 16-bit symbolic unsigned integer will be used. In the following line, we ask DeepState to assume that the value is positive. Finally, the last two lines contain the assertion with the mathematical property we want to verify for the square function. A developer should define such properties for their code, and DeepState will take care of how to verify them or show counterexamples. We use DeepState to check the property and find counterexamples. For this demonstration, we're using Manticore, our symbolic execution engine. DeepState can use multiple other backends such as Anger, libfuzzer, or AFL. After a few minutes, DeepState identifies an input to show that the code has a problem. If we want to use a fuzzer like libfuzzer, we don't have to change anything in the code. DeepState can easily use fuzzing to generate a large number of inputs and try to find a counterexample for the square function. However, it is worth mentioning that it does not perform an exhaustive exploration, unlike symbolic execution. Symbolic execution is very thorough, but you often cannot scale to large programs. Fuzzing scales, but is less complete. DeepState gives you both. After we fix the issue in the square function, we can use DeepState to verify that the code works.